So it's lesson 9. Today we're going to be talking about unit testing in C#. We're going to use most of the tools within Visual Studio. We're going to add also one third-party testing component. So if you want to open up your music store and get it running. Just want to make sure I've actually got the right project open. I want this one. So I know that you've done a little bit of unit testing, probably with Jarrett previously in Java. Did a little bit. So in Visual Studio, it's got a bunch of tools here for creating and writing unit tests. What semester was it? When was it that you guys did unit testing in Java? So a while, like, and you had co-op in between, correct? Yeah, haven't done much. Okay. So I mean, what's the basic idea? What's the point of unit testing? And how is unit testing different from other kinds of testing?
Make sure every line of code is tested.
Okay, so that's kind of the goal, right? That we want to make sure that we've covered all of our code. It's probably not going to be possible within our music store to cover all of it, but we certainly want to do some. I'll just get this launched. What's the difference between unit testing and testing in general?
Testing is the entire project, whereas unit testing is just checking individual methods. Right.
Okay. So unit testing is very specific. We're testing each individual method for all of the possibilities that we can imagine might happen with a particular method. So that would be unit testing. That's what we'll focus on. When we're testing different components and how they work together, that's integration testing. What other kinds of tests might we do? So unit test down at the method level. We have integration tests. So for example, seeing how our application talks to the database. That's not unit testing, that's integration testing. What other kinds of testing might you want to do on an application before you put it into production? Jeff? Yeah, so we're talking about load testing, right? We want to that's the term. We want to put it under load and see, does it still perform with a certain number of concurrent connections, right? We also have performance testing. So maybe it's working, but how fast is it working? Kind of integration, performance, load testing, all of those are more at a higher kind of a system-wide level. How does the overall, and the unit testing is at the most granular level possible, making sure that we've tested all the functions for all the results and all the expected possibilities. Okay. It's also, not only is it important when we're building a new app, it's critical to do unit testing when we're making updates, right? Because we want to make sure that those updates, if we add new methods or we change methods, that those don't now break other functions and features. So by having unit tests written ahead of time, we can make sure we can help kind of minimize that. Alex?
I'm just curious, obviously there was some form, but there an automated testing for the security side of a website?
It's a very good question. There probably are, but not that I know of off the top of my head.
Okay, so it's not like that.
You know what? I'm going to ask that question of a guy who graduated from the program a couple years ago and is working as a security consultant in industry now. And actually, when he graduated 2 years ago, every year at Convocation, there's an overall prize for all graduating students at the college for the student with the single highest average in any program, which he won. So he's one of the only computers, I think he's only the second computer studies student to win. And his average in his final semester was 100. He got 100 in every class. He's a very bright guy. So he'd be the guy I'm going to ask that question to. He actually, a few years ago, he taught the web application security course in the third year, which he hasn't done for a couple years. He's just too busy to do it. But no, that course is a third-year course if you come back for your third year. So we did have him teach that course a few years ago in summer. And we'd love to have him back if he can find the time. So I'm going to ask that question to him because he'd be the right guy to ask. So one of the other things we're going to have to look at, I'm just going to give you a few resources here around this. So I mean, you guys already know the basics of what unit tests are. You've done them in Java. So we're testing individual pieces of code, and our goal is to write it so that when we execute our test, every test passes. But that does mean that we need to check both for expected results we want as well as results we don't want. So for example, let's say we have a details method in our controller. If we pass in a valid ID, we expect to get some kind of object back. So that's one test we want to write. But we also want to test what happens if we pass in an ID and we get no object back. Like let's say we have 100 albums, we pass in album ID 5,000, so nothing comes back. We need a unit test to handle that. Or what happens when we call details and we pass nothing in? Again, we're probably going to get an error or a null back, so we need a unit test. So we may have 3 different unit tests for that one method, right? Because there's one way to get the result we want, and there's 2 possibilities of how we might get results we don't want. So we need to make sure our application can handle all those. A few resources for you here. This is a 4-part series from Visual Studio Magazine, which is all about test-driven development with .NET MVC. It's a couple years old, but basically everything's still current on here. And for each section, you can download the code. So I've borrowed a few things from here. So it's 4 parts. There's also this video tutorial, which I'm not going to show you. It's an hour long, but I've also borrowed some pieces, including some screenshots from here. So here he builds .NET MVC application and looks at some unit testing tools and implementing them. So those resources are here for you. We're going to use this also. We're going to need to install a package. And actually, I'm just going to open this up. I'm not a big PowerPoint guy, but I did find in this video a few really useful visuals. Just to give you a kind of a picture of where we're going. Okay. So one of the issues we have right now is the way that our application is so tightly coupled with our database. Right now, we're going to have a very difficult time doing individual unit testing because our application is talking to the database. We want to be able to do true unit testing. We want to be able to test the methods we've written, but remove the database component from it. Mind you, if we do that, we're going to break all of our existing methods, right? Testing them together, that's integration testing. But for doing unit testing, we're going to need a way to kind of divorce this. So we'll come back to this in a bit. But we've got a NuGet package here, a framework that's going to allow us to kind of, what we want to do is test with basically mock data. We want to remove the database component from our methods for unit testing.
I'm just curious why.
Okay, it's a good question. Why do we want it? Why would we remove the the database from our unit tests?
Is the database isn't the issue?
Right, because when we're testing, if we're trying to unit test, we just want to know whether the logic in our methods is correct and returns the right results. So sometimes we could be testing and get the wrong results, but the problem is actually in the database. Right? So yes, we still want to do integration testing where we are testing our methods integrated with the database, but we also want to be able to test the methods in isolation. Then they're true unit tests. So A, we can isolate problems. B, also unit tests should be really fast to run. And if we're connecting to other applications and other systems, that actually slows down that process. So if we actually look, when we set this project up back in the first week of class, we actually enabled the unit testing option. And we have in our solution, notice our solution says 2 projects, because the first project is the web application. The second project is actually our unit testing project, the Visual Studio Generator. We actually have in here 3 unit tests already. So if you expand the controllers, I'm actually just going to close all my files for now. Expand the controllers, we actually have, right, when we set up the web project, we got a home controller with index, about, and contact methods that just return the views. So let's close some of this stuff up so we can see. We don't need any of this. So here's our home controller that comes with our MVC template, right? We get 3 methods, just returns 3 views. So notice that when we enable unit testing, our testing project actually creates a test controller. There's a reference to the controllers in our other project, and it actually writes 3 test methods. We actually have unit tests already here. These aren't great unit tests, but it's a starting point. So every test method, so a couple things that are different about our controller. So one is all our test controllers are going to have this declaration of test class. And all of our methods have a declaration, obviously, of test method. That allows us to use Visual Studio's testing framework called MS Test to run and evaluate our unit tests. So there are a few other useful cues here. And probably when you did unit testing in Java, you probably had similar kinds of cues. So here before our index method, there's a little blue icon that says we've never actually run this test yet. So it's the same for all of these. And if we go to the home controller, and I actually go to that method, we've never actually probably paid attention to these references, but it tells us in the controller, it's told us this all along, that there's actually 1 unit test for this method. But it's 0 of 1, none of them have ever been run. So when we actually run that unit test, if it passes, our Visual Studio will update the controller and it'll indicate that there's 1 successful test on this method. So we can run any or all of these tests. If we want to run just this one, I can just click on my method. So we can either just execute the test. We can also put breakpoints in it and use the runtime debugger if we want to evaluate line by line what's happening in the unit test. We could just put in a breakpoint and click debug. So let's just click run.
How do you run?
So in the test method, right here, there'll be a little blue icon. Okay. If you don't have them, then you can just click on your test menu and run. Let's run all the unit tests. It may generate those icons after you run it. So it tells us that all 3 of our tests ran. So there's our little test explorer. You can also create a playlist. So if we write many, many unit tests, right, we want to only run a suite of them, we can create a playlist and put certain tests on that playlist. So we're only running that selection. We can run 1, we can run a group, we can run them all. So now if we go back to our home controller, notice it tells us that we've had 1 successful unit test for each of these methods. So the structure of a unit test is really no different in C# than it would be in Java. So we've kind of got this 3-step process. We arrange our test, so instantiate any objects that we need, populate any variables or parameters that we're going to use. We then act, we actually execute the method, we call the method we want. And then we've got assert statements. So we can evaluate what did we get, what came out of the method, and what are we expecting. So in this case, we actually wrote a couple different kinds of unit tests. For index, when we execute the test method, all we're checking is that we got a view back. So we're asserting that what comes out of the index method is a view. Now, this is just checking for any view at all. We could actually change this method to send back a different view like this. Our unit test is still going to pass. We're not checking the name of the view or anything like that. So this is perhaps the world's most useless unit test. Right? If I do this, so if I rebuild and run my index test again, I would expect it's still going to pass. So I can run it, it still passes. So assert that a value, that what we're getting back, either we can assert that something is null, we can assert that it's not null. In about, they've used a different test, right? Our about method puts a message in the view bag, and the about is actually checking that the view bag message comes back correctly. So we've got R equal, right? That what comes out of the view result, the view bag message is equal to that string. So if we want to make this test fail, all we have to do is add a different value in here. If we write the about test now, it should fail. So it'll tell us why. So we expected page X and we got page. And contact, again, just like index, it's really just checking that we got any view back at all. So these aren't starting point. So normally what we would do is for every controller in our MVC app, we would write a test controller rather than putting everything in one test file. Probably better to organize, right? Because we're going to write a lot of unit tests. Putting them all in one file is going to make it very disorganized. The other problem is we can't really divide up the labor that way, right? If the three of us are working together, Keith, you can write the shopping cart controller test. You can write the store manager controller test. I could write something else. Right? So it makes sense for, best practice is for every controller in your application, create a new test controller that maps to it. The other thing, so now my test should pass if I run this one again. It automatically rebuilds, and now that I've fixed it, my test passes. One of the other things we're going to see a little later, notice we're using the home controller for every one of these tests. So we're instantiating it in every single method. There is also a way we can write an initialize method in here. So if we have code that all the unit tests should have, that test initialize method automatically runs before any individual method. So that'll be good because later on we're going to want to set up some mock data instead of our database. We want to use that mock data in all our unit tests. We don't have to keep setting it up over and over again. We'll initialize that first, and then any test method we run has access to the mock data. So instantiating our controllers over and over again, instantiating an instance of the same object, we could just move that to an initialize method instead. And it'll run automatically. So let's write a few methods of our own just to try this. And actually, these methods, I was looking with Jared at what kinds of unit tests you wrote. So the first couple of unit tests we'll write are actually the same ones you guys did in Java, but we can try them here and write the unit tests for them. So we'll write a couple of methods in our controller, and then we'll write a few unit tests. So open up your home controller. we'll just write a sum method. Right, simple method, take two numbers in, add them together. Send back their sum. So now we want to write probably two unit tests here. One where we call this method and we get the result we're expecting. And then we also want to write another one, another unit test, where we make sure if we put in numbers that don't add up together and give us the result we want, that we're also checking for that. So let's go back to our test controller. Put on our test method decorator. Call it sum. We'll call this sum pass because we expect this method will give us the result we're expecting. And we need to instantiate an instance of our controller, just like in the other methods. Like I said, later on, we'll move this to an initialize method. Set up a few variables, X and Y, use any numbers you like. And now we'll execute the method, we'll pass in X and Y. And now we can evaluate the results, right? We can compare our expected result to the actual result. We want to assert that they're equal. Our expected so if we run this test, should pass. So we can run our test. Excuse me. Actually, had I built first, it would have showed that that test hadn't been run yet. It would add it from past tests. It would put in a new list of not run tests. So our sum passes. We're getting the result that we expect to get back here. So in our other version of this, we basically want to rewrite this method, but we'll put in a different expected result. And then we can assert that they're not equal. So we should make sure of that as well. We also do have actually, if we check, we do have, just like you do in your Java IDE, we have the ability to analyze our overall code coverage. So what percentage of the methods and functions in our application are covered by unit tests? So if we look, so in our solution, We've cut 2.8% of our code covered, right? We're not going to get to 100% with our music store. But if we can bump that 2.8% to, I don't know, at least 10% today or by the end of next week, great. We're not going to write all the unit tests. We want to learn how to do it, basically.
So in the general, what they've set up, what would you aim for?
Well, I mean, you'd like to be at 100%. You'd like to have tests, and that's kind of the idea behind test-driven development is you actually write your tests. Before you write any method, you actually write the unit tests first. So that way you never have any code that doesn't have tests. Realistically, how many places work that way? I don't know.
For the project, will it be 100%?
It won't be 100%. There's no way. We'll talk. In terms of how many unit tests you have to do for the project, it kind of depends how much we cover over this week and next week's class. So I may redefine those requirements a little bit and say, well, you only have to test these methods. If we don't get it working in class, I don't expect you to get it to do it on the assignment, right? So if we just get, like in yesterday's class, we basically got the index and details unit tests working. We'll try to deal with the save and delete next week. If we do, then I'll expect that on the assignment. If we don't, then I won't. Okay. So let's write. I mean, I recognize this isn't the world's greatest example of a invalid test, but we'll come back to it and you'll get a better idea a bit later. We should still write one. But keep in mind, our test is not actually going to fail. All our unit tests should pass, but we want to check that an invalid result, if there are invalid results can happen from our methods. So if they do, we need to handle those. So we can basically, I'm going to just pretty much copy everything here and we're going to make a couple changes. So this time I'm going to say my expected result is 40. So if our method, we need to check that what happens if our method is given things that really aren't what we want. So in this case, we want to assert, in this case, that they're not equal. If our expected result is not the sum of our inputs, then we need to make sure the method also gives us a different value. So once we build, notice it adds this new test to the list of tests. It puts it on the left under a test that has not been run. So now if I want, rather than running all my tests, I can just right click. I can either say run anything that's failed, anything not run, or I can run a single test, run my selected unit test. Which passes as we want it to. I realize we probably wouldn't write a unit test exactly like this. This was just to give you the idea of writing both a passing and a failing. So make a little more sense when we're actually working with our data and our controllers. We can check our code coverage, see where we got to now. We're up to 2.97. So you can actually look, curious, if we go into our home controller. So you'll notice, actually I'm going to take that out. We have 100% coverage of our sum method. Just going to take this out for a minute. If we don't write the fail method, I'm curious whether that's going to drop to 50. Oops. I don't think I have a way to run it again. Oh, whoops. What did I do here? Oh. So I'm just going to take that out and see whether that affects my code coverage. Yeah, it does. So my code coverage dropped. Oh, didn't drop here. Interesting. All right. We'll come back to that one. So you notice for about in contact, right, there's still one block uncovered in their unit tests. Okay. So let's try one other method. So we want to make sure that we're covering different possibilities. So let's create a method that takes a temperature in and returns some kind of message about the weather. If it's less than 0, we want a hot drink. If it's between 0 and 25, what are we going to drink? Dasha, what are we drinking? Okay. And if it's 25 or higher, what are you guys drinking? Okay. So now we need to write 3 different unit tests, right? We've got 3 possible outputs here. So we need to test each one of these. So we're going to need a get weather minus 0, get weather under 25, get weather over 24 test method. We're going to need each one. Each one's going to call this, pass in a temperature in the right range, and then we can evaluate the expected return. We'll call this get weather below 0. So what should we do in our arrange part of the test method? We need to do a couple things here. Okay. Yep, what do you want to set it to, Jeff? Okay. What else? We have to do one other thing in the arrange section. Yeah, we need to instantiate the controller. Actually, you know what? That part, rather than doing that part over and over again, maybe now's a good point to use our initialize. So by adding this decorator, just initialize. Now, we're going to need to declare our controller globally in the class now. We'll instantiate it in the initialize, but if we declare it here, it's not going to be available outside to the other methods. Here inside of our class, we'll declare it here. Now that object will be visible to all of the methods in the class. So declare your home controller right inside above your public class home controller test. And then in our initialize method, we can just instantiate an instance of it here. So now we don't have to keep instantiating that object in every method. And we don't even have to call test initialize. It runs automatically, as long as it's got this decorator. I'm just gonna, actually, we don't need home controller. We've already declared it up above. We just need to instantiate it. Instantiate the home controller. Declared above. At the class level. So we no longer need to declare and initialize the home controller. That'll just run. So we don't need to arrange it in here because this runs first every time. Actually, this should probably say get weather below 0 may be valid. Because we need two different tests here. If we pass in a negative number, yeah. So our act, string result. So we want to assert so we expect to get I need a coffee. We'll compare it. So you can build, and then this test will show up here in our list of not run. So we pass in -11, we're getting the result we expect. So probably after each test we write, we should analyze our coverage. So I'm not sure why it says we've covered half of our blocks with one unit test. Well, let's write our kind of warm unit test and see what happens. This time we'll use +11. Notice our test initialize must have run because our unit test didn't fail, even though we didn't initialize the controller inside the unit test. Our controller obviously still executed because our test ran and passed. Oops. Should be. So we should build and run this test as well. And then we can see what's happening with our code coverage. So I'll build, I'll run it. I wish there was a more efficient way to do this. So it now says, okay, we're now at 2/3. So we've covered 2 of the 3 possibilities from this method. So maybe we don't need 6. Maybe 3 will be enough because of the way the method's written. There's really no other, because we have an else. There's no other possibility other than one of those 3. So now we can write our last test. So we should have 100% coverage after this. So we'll build and run this test. And it should pass. And now if we check our coverage in that method, we should be at 100. Which I'll check one more time. So we've got 3 passing tests. Interesting, it's still saying we don't have full coverage. Try one more and see if that changes that number. Well, I will write a test that expects to fail. So I've got a below zero valid. I now have a below zero invalid. So here we'll use assert not equal. Different result. We'll see if that affects our code coverage. I just copied and pasted. I've renamed this one to valid, this one to invalid. So when we pass in a minus temperature, we're asserting that if we get coffee back, won't equal. See if this affects our code coverage. I'm not sure if it will. So our test passes. Now it says we're at 100%, which I'm finding a little bit confusing. I'm not sure exactly how they calculated that. But we do want to write, I mean, typically especially when we're fetching data, we're expecting something back, we should write two separate tests, one that we're at least two, one where we get the object we want, one where we get maybe not what we want, and one where we get nothing back. Those would be those potential scenarios that we'd want to need unit tests for. Any questions about these unit tests so far? These are fairly basic, probably pretty similar to what you already did in Java. Okay. We're obviously not going to unit test the entire music store. But in terms of testing our actual MVC controllers that are working with our data, we'll use the store manager controller. So here's the file. So let's make a new test class and we can start testing some of the methods in here. So down in your test project, in your controllers folder, right click and let's add no, the test will do a bunch of stuff we don't want. Let's just go to add a new item. Just think for a minute where we want to get it from. See if there's a template here for the test controller. Under test. So there's a basic. I guess we can try this under unit test, an empty unit test class declaration. So let's call it store manager controller test. So this will automatically give it that test class declaration at the top. So I picked test from the list of templates, unit test, and then store manager controller test. So we'll add that. So it automatically includes the unit testing library. It gives us a test method. Now, we need to reference our controllers in our web project because we can't access the store manager controller without a reference. So additional. We definitely need our controllers in our web project. We're in a totally different project, so it has no knowledge of the controllers we've written without this reference. Scroll up here for a minute. We also are going to want to add a reference to system.web.mvc. Unit testing is not web specific. It could be testing any kind of C# application. So things like view results that we're checking for, those make no sense without that reference. They won't know what a view result is, for example. So those are the references we'll need here. So let's try and test like we had in our home controller. Let's just go to the home controller test. Let's copy the index method, test method. Just copy that. We'll paste it into the store controller test for a minute, store manager. Go to your home controller, just copy it. And we want to write, we'll just put it here. We'll paste it in. Just going to get rid of this stuff. But rather than the home controller, let's just change this to the store manager controller. We're going to try and instantiate an instance of our store manager and just unit test the index view. Now our store manager index view, if you remember, it actually displays a list of albums when the user's logged in. So I'll just build. We'll load the page. If I log in with my admin account, it will call, and I click on Store Manager, it will actually be calling the Store Manager index view. So I'll log in. So this is the method we want to load, right? That's the method that populates this page. So we're going to unit test that method now. So all we're checking is that we're not actually checking whether there's any data. We're just making sure we can call the method and that we get a view back. So let's run this test. Do you get those little icons now? No, okay. So now it gives me an index. Actually, I'm going to go down and get rid of this test method 1 down here. You don't need that. We'll write our own unit test methods. So now I've got one not run test here, which is my index. Now, unlike our home controller index, it fails. Why does it fail? Yeah, what's it expecting that we're not providing, that didn't exist in our home controller? Store manager controller, so William, you're right. What is it that the store manager controller tries to access? Yeah, right? It's saying there's no connection string here because it looks in the project configuration file, which in our test is called app.config, not web.config. We don't have a connection string. So it's looking in this section here. We have a connection string setting. So we could make this error go away by copying and pasting our connection string called default connection in here. We could do that, but we don't really want to. Why do we want to leave the database out of this? We kind of talked about this earlier. Alex, I'll let you answer because you asked the question.
The test independently from the database isn't an issue. Right.
We want to do unit testing, not integration testing. If we connect to our database here, well, now we have integration testing. We want to test the methods in our controller independent of them accessing the database. The problem is as soon as you instantiate our store manager controller, what's the first thing it does? Connect to the database, uses our model and our database context, and goes. So right now it's tightly coupled. You can't use this controller referencing the database, right? If we take this out, if I take that out, then all of the methods in here automatically fail because they're all using that database object. So that's where we kind of get back here. So this is what we have now, right? We have our store manager controller. That context, that uses entity framework, right? That's this file here, our music store model. So we used our entity framework wizard. Here's the music store model, and it is of type DB context, right? It's our database, it's our class for connecting to the database using that connection string in web.config. So this is where we are right now. All our controllers and every one of the controllers we've built, whether we built them ourselves, like the store one, the store controller, we built ourselves, but what do we do? Connect to the database. The store manager, we scaffolded. The genres, we scaffolded. Every one of them, the very first thing we did was add a connection to the database. So all our controllers are using that DB context. So this is what we've got right now. So unit testing our controllers as we've written them is impossible, because they all require our DB context, which uses entity framework, which connects to our SQL server. So this is kind of a three-step process of how we can unit test. We need to break this. Right? Sometimes you got to break stuff in order to move forward. So we're going to take stuff that's working and break it. So what we want to do is we want to, first of all, inject an interface in between here. We're going to use a repository so that this direct link to the database, we're going to pull that out of our controllers. And we're going to insert another layer in between. Now for unit testing, what happens is we want, rather than actually connecting to the actual database context, we want to just connect to this interface where we're passing mock data. So we just want to create in memory like a list of 3 albums and work with that. And we're divorcing it from the database. So we can do this, right? We can take this out. We could link to some mock repository instead. Then our unit tests work, but then we've broken the actual web application because the web application no longer has access to the database. So our final solution looks like this. So we're going to use a technique, which if you haven't heard before, today's the last day of your programming life. You won't know what this means. What we're going to use is called dependency injection. Anybody heard of dependency injection before? Have any idea what it means? I didn't think so. So our controller is going to link to a repository, and now we have 2 potential scenarios. The first scenario is we're unit testing. So if we're calling our controller method from a unit test, we want to use our mock data. If our controller is unit testing in our live application, our repository is going to call our database context and talk to our database instead. So what dependency injection means is our controller, we're basically going to have to write 2 constructors in our controller. An overloaded constructor. Our default path is going to be this. Our default, when our controller method runs, it's usually going to assume it's calling our actual web application that's in production. So we'll instantiate our controller with no parameters passed. If no parameters passed, our repository is going to say, use the database version and get the real stuff. Our second version of our controller constructor, we are going to pass in some mock data. So if we hand mock data to the controller is going to say, use the mock data we got and don't bother going and instantiating the database connection. So the idea of dependency injection is when one object we can hand an object potentially different things at runtime. So we can either hand it a mock object, or in this case, if we hand it nothing, it knows it's supposed to use the real data. So it's basically an on-demand, a just-in-time passing of parameters or passing of one object to another. So that way we can vary what we're giving an object as we need it. So in order to do this, to make it work like this, we break our controllers. Because right now they're hardwired that they just go straight from here to here to here. So we're going to need to make two repositories, two little interfaces, one for mocking and one for the real thing, the entity framework connection. So we're going to need to make a couple of files in here. So we'll set these up and then we'll take a break. Take us a few minutes to set them up and then we'll have a break. So inside of your models, right-click, we're going to add a new item. And if you go into code, we actually want to create an interface. So the name of our interface is going to be Store Manager Repository. We use this file when we're unit testing and we're going to pass it mock data. This will allow us to unit test our methods without talking to the database at all. Totally in memory within Visual Studio only. Call it Store Manager Repository. So in here, the first thing we're setting up is a list of our albums that we'll just call albums. It only needs a get method. We only need to be able to read the data. Now, we may need to include the artists and genres in here as well because they're subclasses, right? There's a relationship between albums, artists, and genres. We'll leave that out for now. If we need to put those back in later, we will. And now we just need two methods. They're kind of mock methods. We have a save method that takes in an album as a parameter and returns an album object back out. So this save method could do, theoretically, both create and update. And then same for delete. We'll mock up a delete method that takes an album in, returns nothing. So this is used for unit testing, mock store manager data, manager album data. So that's the purpose of our interface. We hand it a sample list of albums and then we can try calling these methods. So we don't need a get or a list method because we can just reference the album's property. Whatever we hand in, that's what comes out when we call get. And then we can also identify a single album from that list. So that's the first repository for mocking purposes. So we've kind of made our mock repository here. We now need to make a separate repository that will actually talk to Entity Framework. So then we're going to, once we have that, we can move this connection out of our controller. That connection lives in our Entity Framework repository. So let's make another interface. So we're going to add, again, an interface. This one we're going to call EF, Store Manager Repository. So this is the one that uses Entity Framework and actually connects to the database. So this is going to be used most of the time. When somebody uses our app in the browser, this is going to handle the database connection now. And then our controller will make a decision which repository it's calling. When we're unit testing, we call the mock one, the iStore repository. When our application's running live, we want to hit the database, we're going to use this file instead. One other thing we should do here is we need to make these interfaces, they should both be declared as public. We create the interface, it doesn't add that declaration. We want to be able to access this from the controllers. So make sure both of these are declared as public. The other thing we're going to do here is our EF Store Manager repository, it will inherit from the other one. So we don't have to redefine the same properties. So the mock one is a parent of the database one. Now this is just a generic repository. Again, it has no knowledge of MVC. So we need to add a few references. It has no knowledge of SQL Server. So added references. We need to reference system.web because it has no knowledge of, any objects to do with web applications. We also need, in order to use entity framework, we need to reference system.data.entity. These things are built into our models. For example, so here's our album model. Right, it's already got system.data.entity here. So what we want to do is we want to add our database connection here instead. This property for album. We can actually write our call right here. When the get method is executed on the albums, we can just say return db.albums. So we don't actually have to write a separate method. The get method can actually call the database. Now we can just simply write our three methods. We can write a get method. Well, actually, we may not need a get method. We've got, what do we have in this interface? So we have a save and delete. We pass in an album. Now this method will be set up to do either insert or delete. Sorry, insert or update. If our album that comes in has an ID, sorry, if the ID is 0, we'll add a new album. Otherwise, we're editing. We'll just mark the existing album as modified. And then we call save. And then we should return this object back with any updates. Whoops. Sorry. We should create this one not as an interface. That's why this should be a class. So it's complaining because it's saying we haven't written, our repository has, our interface has to implement a delete, and we haven't written the delete method here yet. So show potential fixes, sure. Yeah, let's do this. There, when I click that little, now it writes a delete method for me. Didn't even have to create it. Now, by default, there's no code in the method, but it actually generates the method signature, or I could just type it. So in this case, we'll just say db.albums.remove, db. And now we've implemented the interface. So we may need a get method, and we may need a list for artists and genres, but we'll see. So our repository is quite lean here. So all the database calls now get made through here. And our methods will just call one of these two interfaces. When we're mocking, it calls iStore Manager Repository. When we're actually running the application, we'll use this interface. So our interfaces are set up. It is time for us to take a break, right? We've created these two interfaces now. So now what we'll need to do is modify the controller to handle the dependency injection. That's what we do when we come back. So when we instantiate our controller, it will know whether to use this one or this one. And then our methods become agnostic. The actual index, details, create methods, they don't care. But we'll have to modify those as well so they can follow either path. Okay.
Just pop up, just what was after that else method. Save and okay, yeah.
Right. So if it's zero, if the ID is 0, add it. Otherwise, mark whatever comes in as mark the object as modified, and then commit the changes and send that object back. Okay, I will push what we've done so far to GitHub if you need it. And let's take 20. We'll come back at 12:40.